Hey, good morning, everyone. We'll start in 2 minutes.
Yeah, good morning.
Morning.
On you and me.
People will come. People will. Yeah, I think it's the last session. Let's wait for some time.
Good morning.
Good morning. Let's wait for 2 more minutes, and thereafter we'll start. Okay. Because this is the last session, I just want to ensure that. Yeah, go on.
I think today also people will face the joining issue because today also the link is not been updated and signed.
It's the same link that we've been using for a long time. I mean, at least I'm using the same link. So essentially, it asks me to register every time I click on it. I'm not sure on your end how it goes, but for me, it asks me to register. So provide my details, and then I can log in.
Yeah, on each and every day, how the Zen works now, like they'll create a new tab like 13, 15 on a daily basis, and then they'll upload the recordings and then the join class button and all those. Yesterday's recording was still not updated. And the
Oh,
link for
okay.
today was not yet been updated. I don't know, like, what's the point in sending
Maybe, see, I can't say like what's happening because I'm not managing all of that. So I don't know what's going on in the background. The only thing that you could do is maybe request them.
Dinesh, did you inform them?
Yeah, I already did, Rajesh, about it. I think on Monday I dropped an email, but what they were saying is like from your batch, I didn't receive any email or something. I have only from your side that they received. If the feedbacks were coming, then you are happy with the feedback in the way they were saying. And I don't understand because it works in that way. Right? They think that I'm only facing the problem with that.
See, the only thing that you could do is respond right. And see, obviously, if you are facing issues, then you can complain to them. If they don't do anything, then you can again send an email.
That's what.
You can only do reminders, right? You cannot force someone, but maybe you can remind them sternly once. Okay, this is not how it is supposed to be done. I believe everything will turn up all right. Just wait for maybe a couple of days. Maybe like the person who was doing it, he's kind of lagging behind.
And so I think yesterday I was looking for like when I was working, I was looking for some kind of requirements in Naukri, like for data scientist and data analyst. But for that data scientist and data analyst role, they were not focusing that much on ML part. So is that the industry work in that way or?
No, it's not like that. If you want to become a data scientist and if a role is there which is not using any ML, first of all, I'm doubtful. You can show me some listings where there is no ML at all.
Okay.
Okay. So the role will be more inclined towards a data engineer in that case.
Okay.
If it is just about analyzing data, or let's say if there is no ML involved, I'm highly doubtful.
Okay. First, I think I need to have that.
Yeah, you can share any of those listings with me because see, I cannot, I mean, just rely. I mean, obviously I can rely on your words, but it's
Mhm.
strange to me.
Okay.
It's very
I'm
strange to me.
not sure about the company. I think it was a startup in Bangalore or something. It's an
See,
energy.
there could be, see, I'm not saying that like every company does it. I mean, for me to believe this, there has to be like majority of these listings which do it like this. Maybe one or two
Okay.
listings could be there,
Sure.
right? But I would say 99.9% of them would definitely have focused more on ML.
More than ML.
Yeah. Okay, so I think we have three people now. So let's start. Okay, so this is my last session with you. So you guys can tell me if you have any questions, if you had time to go through those questions, and if you want me to clarify some of the answers, like for those questions that you found difficult. Did you get time to do it? Anyone who did? Okay, so assuming you're not saying anything, so I think you didn't get a chance to go through it. So nonetheless, okay, this is the last session. If you can spend time later, okay, and let's say if you can get in touch with me through LinkedIn or any other resource, I'll be happy to provide clarity on that. All right. So today I'm going to discuss maybe some of the projects that you can do in your free time. So I'm going to list some projects. Okay. So and that is like really interesting, maybe to some of you at least. I'll not be able to provide any rigorous problem statements on this, but I'll share these handwritten notes if you can. The reason I can't do this is like those problem statements are proprietary. I do have a document and all that, but I can't share those. But I think these problems are, I mean, quite easy to do. So you can also do it in your free time if you understand like the motivation behind it. So the idea is this. So this problem pertains to GraphML, graph machine learning. You would require either of the following libraries to do this, iGraph or NetworkX. And obviously you would need sklearn, okay, on top of it. sklearn on top of it. So I'm going to talk about like some of these projects which are coming from this GraphML side. They are becoming very, very popular nowadays. So, and I will give you this multitask problem. So instead of solving just one task, you can solve many tasks in one shot. Okay. So imagine a network is given to you. Okay. So you can think of it like a graph where there are nodes and edges. Okay. So imagine this is like a graph which is given. Okay. There can be random connections. Okay. Let's say this is a graph which is given to you. Now you can solve the following challenges. So from a graphical perspective, so think of it as a social network. Okay. So these nodes are edges, and the relationships are, sorry, nodes are people, my bad. Okay. And relationships are these edges are some relationships between people. So for example, let's say you're talking about Facebook. So an edge would represent friendship between two people. So currently it's an undirected graph. Essentially, you can go both ways. I mean, if you are a friend of mine, then I'm a friend of yours. Okay. So that is why it is called as undirected. So, I mean, the relationship is both ways. There is something called as a directed graph. So if you can think of maybe say the Twitter network. So that's like a follower-followee network. You follow someone, right? If the person follows you back, then again, it's a directed network, but there will be two edges now, not one. So if the person follows you back, there'll be two edges now. But most of the times you'll be following someone, right? So you will have an edge from you to that. If somebody is following you, that person will have an edge to you. Okay. So directed networks are represented like this. Okay. All right. So there is an arrow which represents the relationship from A to B. Okay. So this is undirected. This is direct. All right. So I'm going to give you a list of problems that you can do in this, and you can actually solve a multitude of problems in one shot. So one of the big concerns is like the size of this network. One of the big concerns is the size of the network, because the networks can be really big. By the way, if you want to work with such data sets, you can go to there are several websites, okay, where you can download these data sets. The most popular website is Stanford Snap. So Snap is a repository where you can download graph datasets from. Okay, it's a repository of graph datasets. If you just do a Google once, can you just see the web page for once and tell me, okay, if it's accessible or not? Can you just try it out? Can you just type Snap on Google, Stanford Snap, open the first link and see if you're able to see some of the datasets. And maybe say a yes if you're able to see that link. It's accessible, right? Okay. So there are, I think, more than 200, 250 plus data sets that you can play around with, starting from data sets which are in KBs, and then there are data sets which are in terabytes. Okay. So there is a huge variety. So you can pick your poison, like choose whichever sizes, that you can accommodate on your collab or let's say on your laptop. Okay, at least to get started. Okay. So,
So
limit,
that's a GitHub
yes.
repository, right? Not independent repository.
I didn't get you. It's
It's a GitHub repository.
it's not a GitHub repository. It's, you can say, like a drive link.
Okay.
Okay. GitHub is specific to Microsoft, right? Now that they have bought it. Okay. So GitHub contains a lot of other things, right? Not just data sets. So, but this is nothing but a website which hosts a ton of data sets related to graphs. Okay, related to graphs only. So you can download any of these data sets and get started with it. By the way, if you are, if anyone is from a computer science background, do you guys know how to work with graphs? Is there anyone who knows graph representations? How in a computer graphs are represented? Is there anyone who knows about it? This is quite common, especially if you're coming from a computer science background. Okay, maybe give it a read. Okay, it's quite simple. So there are adjacency list, adjacency matrix. Okay. Do you want me to explain what these representations are? Or you can read on your own. Tell me.
If you can explain.
Okay, I'll give you like in detail idea about these representations. So in a computer, you represent a graph in the following way. Okay. So imagine this is like the graph given to you. How do you put it into numbers? That's what I have to tell you. Okay. You guys understand what a list is, right?
Yes.
Okay. All right. Great. Okay. So let's say this is node 0. Okay. This is node 1. This is node 2. This is say node 3. This is node 4. And this is say node 5, 6, 7, 8, 9, 10. Which representation shall we start with? Maybe say adjacency list. Shall we start with this?
Yes.
Okay, so let's start with adjacency list. So what you have to do is you have to imagine that, okay, you're going to create basically a list of lists. Okay, you have to create a list of lists. So the first list would be for node 0. The second list would be for node 1 and so on. Okay, so if you have say 9 nodes, can you see that you have 9 nodes overall? 11 nodes. It starts from N0, goes up to N10. Okay, so you will have a total of 11 rows. Does it make sense? Yes, people, is this clear?
Yes.
Okay, so what you will see here is this. So in the list of N0, you will see all those nodes that are connected to N0. So which nodes are connected to N0? N1 and N2? Yes or no? These are connected to N0, right? So you will just see N0 and N2. Basically, you can write the numbers also if you want. So you can just say 1 and 2. Basically, this is N1 and this is N2. Is this clear? Yes, people, is this clear? So the first list would be just the nodes that are connected to it. Similarly, you see the second list. So you will go to N1 and see which nodes are connected to it. So you have N0, N4 and N6. Okay, so you will just write N0, N4 and N6. Okay, so basically what you're storing is the nodes that are directly connected. Okay, that are adjacent. Okay, that's why the name adjacency list. Is this clear? Yes, people, is this clear? Is the concept of adjacency list clear or not? Tell me, I'll repeat this otherwise.
Yeah.
Okay, so this is adjacency list. Okay, so this is one way in which you can store your graph as numbers. Similarly, if you think of the second representation, which is adjacency matrix. Yes.
Can you repeat that once?
Okay, so look at this N0, this node 0. Okay, I'm highlighting this N0. Okay, which two people are connected to it?
N1 and N2.
N1 and N2, right? These two.
Yes.
There is an edge between them, right? Yes or no?
Yeah.
Okay, so just write for N0, for this list of N0, you just write 1 and 2. The numbers, the node numbers, you can write it as N1 N2 if that's what suits you. Okay. You can write it as N1 N2, that if that's what suits you, that's what suits you. Okay, I'm just saying it as 1 and 2 because you'll be dealing with numbers later on.
Okay.
So you would have to strip N. Okay, you would have to strip N. Is that clear?
Yes.
Okay, similarly, if you look at N1, what are the connections to it?
N0, N2.
N4 and N6,
Yes.
N0, N4 and N6. So just write 0, 4 and 6 here. Clear?
Okay.
So you do it for every node. Okay, you do it for every node. Okay, and that is what an adjacency list is. I'm going to show you what adjacency matrix is. So this is like one hot encoding, the structured representation. It's like a tabular representation that you guys use. So imagine that. So this would be like a n cross n matrix. So if you have 11 nodes, okay, starting from N0, N1 to N10, so this would be 11 cross 11 matrix. Okay. So now the first thing is, if you have a 1, which means that there is an edge. Okay. If you have a 0, which means that the edge is absent. Okay. Is this clear? It's like a structured representation that I'm doing here. Okay. This we have seen, right, in transaction encoder. One hot encoding. It's the same thing. Okay. So N0 is connected to 1 and 2, right? So just put a 1 and 2 as 1. Okay. If N1 and N2 would be 1 and everything else would be a 0. Okay. For N1, the numbers are 0, 4, and 6. So 0. So let's say there is somewhere N4. Okay. And maybe say N6 here. Okay. And everything else would be a 0. Is this clear?
Yes.
Okay. So this is like a tabular representation for you guys. So you can use it. Now, I hope you understand what is the limitation of this one. Size is exponential. Here, size is more, right? In comparison to this.
Yes.
Okay. Another issue is, I mean, if size is more, you can think of it as, but retrieval would be faster. Like if you want to know if there is an edge, okay, between say 0 and 4, you can directly go to this number without actually having to go through previous numbers. You can directly go through this number N0, N4. And if you see a 0 there, you can say that, okay, there is no edge. Okay. But if you look at this representation, if I ask you, is N0 connected to N4? What would you say? You have to search, right? Can you say it without searching?
No.
No, right? So you have to search. So this takes time. Retrieval is slower in this case. Okay. Even though it has less size, retrieval is slower. Here the retrieval is much more faster. You can directly jump to a memory location. It's like a grid. a matrix. Okay. All right. And what the hell is this edge list? Okay. So edge list is nothing but the collection of list numbers. Okay. So the idea is look at this first edge. Okay. Let's say if you look at this edge, which I'm highlighting, what would you call this edge to be? Like what it is connecting N0 and N2, right?
Yes.
Okay. So write down the nodes which are connecting to it like this, 0 and 2. So node 0 is connected with node 2. What would be the second edge? 0 and 1. What would be the next edge? 1 and 2. So just note down. Okay. The edge numbers. Okay. Which do you think is the most efficient, by the way? Which do you think is the most efficient? Okay, okay, let me put it this way. You are thinking in terms of space. Which do you think would be the most efficient? Let's say for a sparse graph, if one node has only a few connections, which do you think would be the most efficient representation?
This.
Edge list. Okay, if only there are a few edges. Okay. The next one would be that adjacency list, and the final one would be adjacency matrix. But which would be the fastest to access?
Matrix one.
Matrix one. Okay. So again, you have to think. Okay, in this direction, you guys are right that okay, you can represent graphs like this. Okay. So these are three popular representations which people use. Depends on what you are given. You can convert it to any representation. So you can transform one to the other by using packages. They are quite common in this iGraph or NetworkX. Okay, use this or this. My suggestion is use iGraph. iGraph is what we say is more flexible and it is faster as compared to NetworkX in terms of performance. Okay, but NetworkX is also not far behind. Okay, I would suggest you go with iGraph, but you can use NetworkX also. So once you get the data, you can convert it to a graph. You can even visualize it and all that. There are functions for it. So now what are the problems that we can solve? Okay, let's think about, okay, this is the data which is given to you. Can you think of what are the problems that you can do? Think that, okay, you belong to a social network. What kind of problems would you like to do? Anyone?
Friend suggestion.
Which problem?
Suggestions.
Okay, so suggestions of what?
People you might know.
Okay, makes sense, right? Yes or no? So how does Facebook recommend friends? So this is called as link prediction. Okay, the first problem is called as link prediction. So essentially what it is saying is, okay, let's say so you know that networks evolve over time, right? New connections are made and existing connections might be broken. Yes or no? Like you make new friends with the time. Does that make sense or not? So essentially what Facebook is saying is that if the probability of, let's say, do you see N0 and N4 are not connected right now? Okay. But can you think of something, okay, if the probability that, okay, N0 and N4 will become friends later on, okay, what is the probability that N0 and N4 will become friends later on? If it is high, don't you think I can, give it as suggestions?
Yes.
Okay. That is what you have to figure out using link prediction. Okay. I'll give you an idea of how you could do it. Okay. So, can you think of creating a list of features from a graph? Okay. Think of creating a list of features from a graph. So you are doing essentially feature engineering from graphs. So what features can you make from a graph? Okay, let's look at N0. How many connections it has?
2.
3, right? Currently 2. I assume N0 and N4 is okay, but it is 2, right? Yes or no? 2 edges. Okay, so can I say, so this is called as degree of the graph. This is called as degree of the graph. Now, if it is a directed graph, we call it in degree and out degree. So there might be edges which might be incoming, and there might be edges which might be outgoing. So we divide it into in degree and out degree. Okay. So this is, say, the degree right now. For a node, how many edges are coming from it? Does that make sense? That would be one feature. Yes or no?
Yes.
Okay. So think of it like this, that you are trying to, okay. So basically, if you have, say, 11 nodes, okay, assume that you have 11 nodes. How many pairs are possible?
11 choose 2.
11 choose 2, right? So can you write these pairs? You can, right?
Yes.
Okay, so you think of, you have written all these pairs. Okay, so for every pair, I'm going to make a list of features. So can you note down degree of n0? Can you note down degree of n1? These will be two features, right?
Yes.
Degree of n0 is 2, degree of n1 is, I mean, we can check. What is degree of n1? 3, right? Sorry, 4. Yes or no? So you can note down 4 here. Okay. And the output is, are they connected? Are n0 and n1 connected in the graph?
Yes.
Okay. So can you say it's a 1? Does it make sense? So can you do it for all possible pairs? So for some pairs it would be 0, for some pairs it would be 1. Yes or no? Does it make sense?
Yes.
Okay.
Yes.
Yeah.
So what this problem is, if you think about it,
It's a classification. problem.
binary classification problem. Okay, so you have reduced your length prediction problem to binary classification. Okay, let's see how we are going to do about it. So I've just told you degree. Okay, so let's think of some more features. Okay, so this is the graph that is given to us. Okay, can I ask you how many friends of n0 and n1 are common? How many common friends are there between n0 and, which is the common friend of n0 and n1?
N2.
N2.
N2. Can I make the number of neighbors as the number of common neighbors as one of the features?
Yes.
Okay. This is called as common neighbors. Okay. Count of common neighbors. Does it make sense? So do you think you can construct a lot of these features using a graph? I'm just giving you some ideas. So if you read a little bit about graph theory, okay, you will read about concepts like centrality measures. Okay. So centrality measures are of different types. So they measure like how important a node is in terms of several things. So there is degree centrality, node centrality, betweenness centrality, and so on. Okay. So you can extract those as features. Okay. You can think of making a histogram. Okay. So currently, if I ask you how many nodes are directly connected to n0? 2, right? N1 and N2. Yes or no? Okay. So if I ask you, I'm going to make a histogram. Okay. So this is my histogram. Please see this carefully. This might confuse you. Okay. So the idea is this: how many nodes are of degree 1? How many neighbors, okay, are of degree 1?
N7, N5.
No. From n0, just look at n0 right now. Okay. For n0, how many neighbors are of degree 1? Is there any? Look at neighbors of n0. Okay. Look at neighbors of n0. And is there any neighbor with degree 1?
No.
Okay. Okay. So do you write it 0 here? How many neighbors are of degree 2? 0.
Yes.
How many neighbors are of degree 3?
1.
Which is that?
No neighbor.
No neighbors. How many neighbors are of degree 4?
1.
2. See, n0 is connected to n1 and n2.
4, 5.
What is their individual degrees?
For N2, the degree is 5.
It is 5. So, okay, this would be 1 and degree 5 would be 1, right?
Yes.
Okay. Does it make sense? So you can go up to what value? What should be the highest degree if you think about it? It should be
Number of nodes minus 1.
can I say that it should be the degree of the node having the highest degree?
Yes.
I mean, we have to go up to that number, right? Because for some other node, maybe it has degree 7. Yes or no?
Mm.
Okay, so whatever is the maximum degree, let me call as degree max. So this vector would look like a whole big vector up to degree max. Okay, so you have just done it for n0. Can you do it for n1 also? So you have done it for n0. Can you just concatenate the vector for n1 also? Yes or no? Does it make sense or not?
Yes.
Okay, so this way you can get more and more features. Okay, and okay, let me give you more hints, like how you can think in a more intelligent ways. So currently, okay, like one of the biggest problems of a graph is that I mean it's very difficult to process the entire graph. Okay, so I currently I'm looking at this one level neighbors, right? Yes or no? I told you one of the features was a one level neighbor of n0 and n1, which was n2. Do you think you can look at two level neighbors? Yes or no? So n0 and see, if you look at n0 and n1, which is the direct neighbor n2? If I ask you what are the neighbors that are connected by two edges, what would you say? What are the neighbors that are connected by two edges? Is n6 connected by both of them with two edges? It is, right?
Yes.
Yes.
So n from n0 to n1 and then n1 to n6. And similarly from this to this. Yes or no? Okay, look at n4. Is n4 also connected by two edges?
Yes.
No.
That if I'm considering the n0.
No, no. Which edge would you take to reach to say n4 from n1? It has to be two hops. It has to be two hops. You have to take two edges at least. Two edges, sorry, exactly two edges. See, from n0 to n4, you can reach from n0 to n1 and n1 to n4. Can you reach from n1 to n4 in two hops? Exactly two hops. Which edge would you take? Which two edges would you take? It's not possible, right?
Yes.
Okay, so n4 is not a common neighbor at two hops. Is n2 a common neighbor? Yes.
Yes.
Even at two hops, it is a common neighbor, right? Okay, so do you think you can do it for two hops? You can do it for three hops. But as I am increasing this size, do you realize that I am increasing more amount of local information? Yes or no? I am trying to, with respect to a node, do you see that like I am jumping, I am using more and more edges if I try to accumulate more information, and that will take more time. Does that make sense or not? If you want to make these additional features, wouldn't that take more time? And wouldn't that require even a bigger graph? So let me tell you a concept which is called as an ego graph. Okay. So an ego graph of a node. So this is for a node. An ego graph of a node is defined as, so you can define it, say up to one edges or two edges. Okay. It is, and even more. So if I ask you, what is the ego graph of M0? Let's do it for M0. So start from M0. What edges can you go to? M2, you can go up to N1. Is there any other node that you can go to in one hop? Is there any other node that you can go to in one hop, one edge? No, right? Yes or no? This is called as the ego graph of node N0 with one hop. Now, can you make an ego graph of node N0 with two edges? What edges would you add? What edges would you add? Maybe N3? Yes or no? From N0, you can go to N2 and then you can go to N3. You can go to from N2 to N10. Okay. Any other things? From N1 to N6. Okay. From N1 to say N4. Is there any other node that you can go to up to two edges that are missing? No, right? Is this clear? Have you understood the concept of ego graph? Ego means that you are egotistical. Okay. And you are looking at yourself in the center and you are going up to one hop or two hops or three hops. Okay. Hops are edges. So you can make a graph keeping you in the center and then you are seeing how many people you can reach. Is this clear? So it's like your friendship network up to 2 edges or 3 edges. Yes or no? Is this clear or not? Yes, people. Ask me if it is not clear. If you don't say anything, then I don't have much to say here as well. So this is something that I'm saying you should go beyond and learn. Someone please. Is it clear or not?
Yes.
Okay, great. So the idea is if you keep on increasing the edges in the ego graph, you are taking more and more information, but that becomes more compute intensive. So what you can do is that once you create this data set from the ego graphs of nodes, okay, from the ego graphs of nodes, you can make a check. Okay, you can make a check. So if you increase the ego graph size, okay, if you increase the ego graph size, let's say you are measuring accuracy as the performance metric, using accuracy as a performance metric. So what you will see is that after, so initially it will increase and then after a while it will settle. So basically you want to know what should be the ideal number of edges. Okay, ideal number of hops that you can take to get to the best performance, beyond which the performance kind of stagnates. Okay, so this is one experiment which you could do. So the idea is for a given pair. So let's say if I break this down into train and test. Okay, if I break this down into train and test, and I'll give you some ni comma nj. I'll give you the vector of this ni comma nj. If you pass it to say logistic regression, what should be the output of logistic regression? It will give you a probability score, right? Between 0 and 1. Yes or no?
Yes.
And if the probability score is, let's say, greater than a number that you decide, you say that, okay, this is a friend which is suggested to you, otherwise no. Okay, so something that you have studied, you can relate to this here. Okay, this is called as link prediction. Let me give you more insights. What other problems can you solve with this? There are so many problems that you can solve. Okay, so one of the things that you could do is maybe you guys know clustering, right? Okay, you guys know clustering. Okay, so the question comes, like if you extract these features, okay, so don't now think of these node wise. So what you will do now is you will make a data set like this. So every row will be corresponding to the node features. So if you have say k nodes, you will have k rows. Okay, so again you are generating local features only. So generate local features from the ego graph. From the ego graph. So once you generate the local features, for example, degree, histogram of the neighbors of N0, you can think of degree centralities, betweenness centrality, and you can explore more. Okay, there is no limit as such. Okay, so do it for every node. So once I have these features, do you think you can do clustering on it? Yes or no? Once I give you these features, can you do clustering on it? You know clustering algorithms, right?
Yes, yes.
So once you have these features, you do clustering on it, okay, and figure out which nodes are similar or which nodes fall into the same cluster. So essentially what you are doing is structural profiling. Okay, so this could be used in applications like which people are ideal replacements for a given candidate. So if two people are similar, they fall into the same group. Like one could be replaced from the other. Okay, so think of say maybe BJP trying to find an electoral candidate. So they know, okay, this person is a good representative, but somehow that person is not available. So what they will do is they will try to construct some features of that person, and they will try to find which other people are similar to it. So essentially you are doing the same thing, but you are doing it from a structural perspective, network structural perspective. So this is called as using network structure. You are only utilizing the network structure to generate the features. Do I have informations like which is an actor, which is a celebrity, or maybe say which is a micro influencer, nano influencer? Do I have all those details here? No, right? I don't have those. So if you have those details, you can make a feature out of it. But if you only use a network structure to figure out which people are similar based on their connections, you can actually use it to a very decent extent, okay, and find suitable replacements. You can think of, let's say if you know that a person is popular in a community, you can think of doing marketing with respect to that person. All right. Now, a similar concept of clustering is there in graphs also. Okay, a similar concept of clustering is there in graphs also. So let me make a small graph to illustrate something. Okay, let's say if this is a graph. If this is a graph, okay. Okay, let's say there are edges between these people. Okay, maybe like this. So there are edges between these people and like this here as well. Okay. Just randomly connected. Okay. My question is this. How many communities do you see in this network? How many communities do you see in this network?
2.
Two, right? These two. Do you see that these communities, they look very different from a cluster? When we define communities, we say that people are well connected, right? Within the community. These people are well connected with each other. Even these people are well connected with each other. When I say well connected, there are like strong connections between them. Okay. This is called as community detection. It uses the idea of clustering, but for graphs. Okay, but for graphs. So you can explore this aspect also. There is a whole lot of algorithms in this domain. You can make your set of local features and do community detection on top of it. Okay. So this is like another problem that you can target. Let me give you more problems, okay, that you can solve. Okay. So let's say I give you a network, okay, maybe like this. Let's say this is a network. Okay. I'm going to give some nodes. Let's say this is N3, this is N4, this is N5. Maybe say this is N1. Out of these nodes, what do you think is the most important node? Out of these nodes, what do you think is the most important node?
N3.
Why? You're right. Okay, but why?
There are 2 communities, and joining that, I can see one N3 node in common for these 2 clusters.
So can I say that a node is more important if it kind of holds the network together?
Yes.
Yes.
Okay, makes sense. Okay, that is what the interpretation is, right? In the brain.
Yes.
All right, let's see. So there is a network, or I would say there is an algorithm which is called as K-shell decomposition. Okay, so the data would look like this that you have created already, like this. Okay, but I'm trying to solve one problem, which is this output now, and this output will now represent the influence of a node. Okay, you can say the strength of a node in connecting the network. Okay. Let's see how do you determine it. I'm going to tell you an algorithm, and then you can use this data to apply it on other graphs. Okay, that's how you can use ML on it. So the idea is this. Look at this data, and if I ask you, out of these nodes, which nodes do you think are, out of the ones that I have listed, which nodes do you think are having degree 1? Which nodes do you think have one incoming edge, one edge?
These leaf nodes that we are like.
Nodes, right? N1, N5, these ones
Yes.
that I'm highlighting. Okay. Can I say these will be the least important? Yes or no?
Yes.
Okay. So what this algorithm says is this K-shell decomposition, break your data into multiple buckets. Okay. So first you are going to make bucket of degree 1 nodes. Okay, so all these nodes will be disconnected from the graph, and you are going to note down their names. Okay, you're going to note down their names. Okay, you're going to note down their names. Okay, so imagine that. Okay, there was a node like this. Okay, there's a node like this. Okay, so I will say that. Okay, I want to show you something. Okay, so this node would be disconnected, right? The one I have made right now, this one.
Yes.
Okay. Now, do you see that after removing these degree 1 nodes, there are new nodes which are of degree 1? Which are those? This. Is there any other which is degree 1 after disconnecting degree 1 nodes? Is there any other node that, so what you will do is you will put these nodes in this bucket. Okay, you will put all these nodes in this bucket. You will put all these nodes in this bucket. So after you remove these nodes and the corresponding edges, my question is this: some new nodes will be found which will be of degree 1. That there is one node which you see here. Yes or no?
Yes.
Okay. So what you do is you again add it to this bucket. Okay, you again add it to this bucket. So do you think after removing this, is there any degree 1 node remaining?
No.
No, right? Almost all the nodes are of degree 2 or higher. Yes or no?
Yes.
So after you are done with this process, that there is no degree 1 node remaining. So keep on recursively pruning the nodes unless there is no degree 1 node remaining. So they all share the same influential power, which is the least power, which is called as bucket or shell number 1. This is called as shell number 1. Okay. Now, what do you think will be shell number 2? You can answer this.
All nodes with
Bucket
degree
of
2.
degree 2.
All nodes will degree 2. Okay. So what you will do is you will remove all nodes of degree 2. So if you remove all nodes of degree 2, what do you think? Now, some new nodes will be found which will be of degree 1 and degree 2.
Yes.
Okay. So you will put all those also in degree 2 bucket. When do you think this algorithm stops? So it will stop at some shell of kth node. Yes or no? Where the bucket is of degree k. Okay. Now the question is this: if you think of the influential power, can I say the influential power increases? Yes or no? As you go down this algorithm. Does that make sense? So as you go down the shell numbers, don't you think that the influential power increases? And N3 will lie in actually the strongest bucket. Does that make sense or not? Is it clear or not? You can make such a recursive algorithm. I mean, you don't have to make a recursive algorithm like this. It is already there in iGraph. Use it. Can you write the shell numbers here? Okay, can you write the shell numbers here? So maybe say this one is shell 1, this is shell 3, this is shell 4, and so on. Okay. I have a question for everyone. If I give you this data, can you make a regression algorithm to predict the shell numbers? Yes or no? Why am I not saying it's a classification algorithm, by the way?
Because shell numbers can be 1, 2.
Can go up to 1 to infinity, right? Okay, so for a new example, maybe it's coming from a new graph. Shell numbers can be even beyond the shell numbers that are here, right? So if I frame it as a classification problem, it will be problematic, right? Yes or no?
Yes.
Okay, so you have to frame it as a regression algorithm. Okay, so you can say that you are now trying to predict the influential power. Okay, the connectivity strength of a node. Is this clear? So this is another problem that you can do. Shall I show you more problems? Shall we do more problems on this alone? On a graph data set, let me tell you, you can solve many such problems. Okay, the list is actually endless. Okay, list is actually endless. I mean, if you give it a read, you can make a multitask. Okay, make multiple outputs and train models for each of them. Okay, train models for each of them. This is, I mean, a very classical problem. Very rarely people use it. So you can actually make a module of multiple tasks and combine it together. And maybe if you're interested, read about stacking a little bit. Okay. So if you know about stacking, this will actually improve your results further. Okay. This will improve your results further. Shall I tell you what stacking is?
Yes.
Okay, it's a common machine learning idea, but okay, this is used like this. Imagine you are given a set of features.
Is it stack and queue that we study?
No. The idea is the same, but it's used in the context of ML. It's not data structure stack.
Okay.
The idea is of building a stack, but using a machine learning algorithm stack. Okay. All right. So imagine now you're trying to predict multiple outputs. Okay. So one thing that I can do is I can train a model using the input features and predict the individual outputs, right? Yes or no? Does it make sense or not? So how many models do I have to make? How many models do I have to make? If there are k outputs,
Okay, yeah.
k, right? K models, okay? Now, what I'm saying is in stacking, you do it a little differently, okay? So if you are doing it like this, what you are essentially ignoring is the relationship between these outputs. When you are doing it like this, you are ignoring the relationships between the outputs. So these outputs can also be correlated, right? Yes or no? If you treat them as separate outputs, these outputs can also be correlated. Don't you think they can act as features for predicting something else? Okay, let's see how. Okay, let's see how. So please note that they are outputs. Okay, they are outputs. Okay. So the idea is this. What you will do is you will build a k-stage pipeline. You will build a k-stage pipeline. So the first task is use the D features and try to predict Y. Okay. Use the D features, try to predict Y. Okay. So using this model, don't you think I will get Y hat? Let me call it Y1. So I will get Y1 hat. Yes or no? I can find the prediction for a given input, right? Using the model F. Does that make sense or not? So prediction, so for any new example, I can do this, right? So the prediction would be, I can compute the prediction from the given model. Okay. Let's call it model 1. So from model 1, I can get the predictions using Y1, okay, of the output Y1. What stage 2 will be? So now you have started building a stack, okay. What stage 2 would be, use the predicted outputs of Y1 hat and try to predict Y2. So this is your model 2. So model 2 uses the prediction from model 1 as an input feature and tries to predict Y2. Okay. So similarly from model 2, you predict Y2 hat. And don't you think this can be continued for k stages? Yes or no? Does this make sense or not? This is called as stacking. So essentially you are stacking these models one on top of each other. The output of one acts as the input feature for the other. Okay. So this is how the pipeline is built. And this is how the pipeline is built. Is this clear? This typically gives much better out than you would have if you would have trained individual models. Okay. So for a multitask machine learning algorithm, you do this. Okay. So I would say that you read about even blending. Blending is a form of stacking only, but blending is not preferred. That's why people prefer stacking. Okay. See what is the problem with blending. Read about stacking a little bit more. You should focus on how to split the data. This is the most important part. How to split the data for building the stack models. Okay. Focus on this because see, if I start covering everything, then I would be teaching stacking only. Okay, that's not the job for the day. Okay, because this will be important. Okay, how do you split your data to create the stack models? Okay, because if you do it like if you use the train data for building all your stack models, it would overfit. Okay, you cannot pass the same data to every model. Okay, you cannot pass the same data to every model. You will read about it. Okay, once you read about blending does it. Blending suffers from this overfitting problem, and that's how stacking overcomes it. So stacking partitions your data in a much different way. Shall I tell you how it does it, or you can read on your own? Can you spend some time in reading about it, or shall I tell you right now? What do you recommend? Would you? Please see, this is an external project that I'm suggesting. If you are really interested, really curious to do this. If you're not curious at all, then don't do this. Okay. But this is something, if it is there on your portfolio, it will look really well. Okay. So this is one of those projects. Okay. Do read about it. Okay. I mean, I can tell you it's not a big deal, but if you're not able to explore on your own, after a while, it will become difficult for you to work in the industry. Because this kind of field requires you to explore. Not just this, data science, essentially. Okay, so this was okay. I can tell you even about more problems. If you give it a read on your own, you will see there are so many problems that you could do with just GraphML, and there is whole plethora of articles on it. So do make one which has a multitude of applications in one shot. Nobody has attempted it. Let me tell you this. So it could be a really good project for you. I'm telling you from my experience, nobody has attempted the start version of these models. Okay, so you would be the first one to do it. Do think about it. You can publish this as a research article also. Okay, but you have to generate the results first. Okay, so this is something actually I am doing it right now with some of my you can say students. So we are really interested in this. That's why I'm telling you this project exists, and it is very much closely related to your data science, but now on graphs. Okay, I'll tell you maybe more about more problems that you could do. Okay, let me think which one should I tell, because there are many which are very, very popular. Okay. So I don't want to tell you problems which are related to ML engineer or AI engineering side, because that would become even more difficult for you. So I want to ensure that like there is a proper balance between data science and ML. Yeah. Okay, I think I spoke about this, but if you're interested, you can do this. Okay, I'm just going to repeat what I said earlier. So you can build an information system. You can call it an information retrieval system. Did I mention about this? I think I did, right? Yes or no? Did I mention about the system earlier?
Yes.
Okay, so maybe you think of making one information retrieval system. It could be about text, it could be about images, it could be about sound. Okay, so basically you can make it multimodal. Like there are different modalities, right? Text, images, and sound. Okay, so think of it like this. Okay, so how YouTube does it? So if you are watching a video, okay, if you're watching a video on YouTube, how does YouTube recommend you new videos? Okay, how does YouTube recommend you new videos? Let me tell you, it takes all the modalities together. Okay, it takes all the modalities together. So you can make one like for your task. If you are just thinking of text, so the idea is this. So imagine you are given say, you guys do you guys use ChatGPT? So I can include that as well in this project.
Yes.
Okay, so maybe I'll give you a nice integration of ChatGPT with this. Okay, so the idea is this. Let's say we are thinking of say making a chatbot kind of a thing. Okay, well, not just a chatbot, but obviously chatbot is also an information retrieval system, like one of a kind. So if you ask a chatbot a question, okay, what chatbot does is it actually goes to the database, okay, and fetches the most relevant article, okay, fetches the most relevant information for you. So what I'm going to say is this, how you can achieve it. So let's say you want to do it for a specific purpose, okay, let's say you want to do it for a specific purpose. So the idea is this. So maybe you have collected a lot of Python articles. Okay, maybe you have collected a lot of Python articles, and these articles are nothing but they are coding instructions written along with the text. So basically, let's say it is describing the usage of different libraries like pandas, NumPy, SciPy. Okay, and somebody asks a question. Okay, can you tell me how do I do group by? Okay, so the question is, how do you group by using? How do you group by in pandas? Okay, so this is the question. And now you have a set of articles. In some of these articles, you have information about, okay, you have information about pandas for sure. Yes or no? You would have it, right? Does that make sense or not? Okay. Now think of this. What you would do is, okay, I'm assuming these articles are in PDFs. Okay. So get a PDF parser, okay, A parser is you can say a package which can convert a PDF, which can get the text from the PDF. So from a PDF, you get the text. Okay. So see, it could be a cheat sheet also. Okay. So once you get the text, what you are going to do is you are going to break it down into sections. So this text will be broken down into sections. You can call it as paragraphs. Okay. You can call it as maybe say a set of lines. Okay. But you have to decide, okay, how you are going to break it down. Okay. Maybe you do paragraphs or sections depending on where the break is available. Okay. So let's say this is portion 1, this is portion 2, portion 3 or paragraph 3 and so on. Okay. Now, I'm going to say like this. From portion 1, okay, if I give you portion 1, it would be about a piece of text, right? It would be a piece of text. Let's say portion 1 is talking about variables in Python. Okay, this is a let's say a pandas cheat sheet, and portion 1 is talking about variables in Python. So it will have text, right? It will say that, okay, what are variables in Python? You can say variables are containers which store a value. It could be float, it could be integer and all that. Okay, so paragraph 1 contains about variables. So if you feed it to ChatGPT, do you think you can ask ChatGPT to generate questions? Yes or no? So given this portion 1, can you ask ChatGPT to generate a list of questions that could be asked? Can you make use of ChatGPT for it? Yes or no?
Yes.
Is this clear?
Yes.
So you can maybe ask ChatGPT to generate say 10 questions. Okay. So for each paragraph, can you do it? Yes or no? For each paragraph,
Yes.
do it. Okay. So you can, so for each paragraph, you have a list of say 10 or maybe 5 questions, whatever is the limit that you have in your mind, or maybe limit due to the limitation of your database in which you'll be storing it. You can keep it like this, right? I mean, you can decide the number of questions that you want to have. Now, a chatbot is always asked questions, right? A chatbot is always asked questions, okay? Now, I have a set of questions for every paragraph. What is it that I have to do? Think about it. I have to convert it to a vector representation because do you remember where I'm going with this? We saw that we converted text to number representations, right? Which representations do you remember? Bag of words, term frequency, TF-IDF. Do you remember send to vec? Do you remember BERT embeddings?
Yes.
I showed you all this, right? You can use any of these embedding representations, okay, to convert your given text to a set of numbers. And don't you think that you can do the same for every question also that you have generated? So store it in a database. And for a given question, whatever representation that you are choosing, you try to find the similarity. So for the representation of the question, you try to find the similarity with all of the questions in the database, and whichever question is the most similar, don't you think I can retrieve the relevant paragraph for it?
Yes.
And then you have a chatbot with you. This is what is an essential information retrieval system. It doesn't even require you to train a network of any kind. Okay, it's a very simple and elegant solution. Okay, which makes use of ChatGPT for it. I can actually give you several suggestions and pointers to improve upon it, but that would become more advanced. Okay, so currently I'm showing you with something that you can relate to. That's why I said Python articles. Okay, you can think in terms of maybe say, so I'm doing this for my college. So where I'm trying to retrieve, you can say authors, relevant authors who can review a paper. So we are hosting a conference in the month of September, and we get a lot of submissions. So a submission is nothing but a research paper. So we have to assign a research paper to a potential set of reviewers. How do I know which set of reviewers are appropriate for an incoming research article? So what I do is, for each of my reviewers, I collect a list of PDF articles. Then I convert their PDF articles to embeddings, and I simply match for a given research paper, which research paper's embedding is close by. And whichever is the closest, or I take the top 3 or top 4 reviewers and I assign it to them. Does it make sense? Yes or no? Was the idea clear for a conference reviewer system?
Yes, yes, totally.
So this way you can do it for PDFs, you can do it for images. So let's say if somebody gives me an image, how do I, so you have, you know that image is a collection of pixel values, right?
Yes.
Okay. So for images also, you can use these image representations, which are called as image embeddings. There are many models. Okay. You can use models like, I mean, if you go dive into the realm of deep learning, there are models like VGG, exception, inception. There is a whole plethora of a list of models. Okay. So use any of the models, get the embeddings from it, store it, and for an image, get the embedding, and for all the set of images in your data set, you get the embeddings. Try to find the images which are most similar, or do clustering of images. And if an image belongs to, so let's say you do k-means, okay? I'm just giving you more ideas about how to work with images. So you do clustering on the embeddings of images. Let's say you are doing it with k-means and say 10 clusters. And for a new input image, don't you think I can predict to which cluster it belongs to? Yes or no? If I am doing k-means, you can do the same for text also. There is no harm in it. Okay, but for text, this approach which I'm telling you, we're comparing the embeddings. Even though it is expensive, you can reduce it with the help of clustering. That will save you some time. Okay, so then you have to match it only with the samples in a cluster. Okay, to which the centroid is the most closest. So you can utilize all the existing techniques that you have learned to make these projects more effective. So you have to think along these lines. Okay, you have to think along these lines. So these are some of the things, you can say some of the projects that I can suggest you. You can do. Okay, I'll maybe suggest you some other projects that
You meant by the Python articles, right? So selectively, I take a Python articles or from the.
you can scrape Python articles from the web. How hard
Okay.
it must be? It's not very hard, right? So you need to use scrapers like Beautiful Soup. Have you used this already?
No.
You've used SNS Scrape for Twitter, right?
We haven't gone for Twitter.
Twitter.
till now.
Okay. Any scraping tool that you have used so far to collect data? No?
No.
Okay. Maybe explore along these lines as well, because these APIs, sometimes they are asked in interviews. Okay.
Okay.
Because people want to know if you know whether you have done a project on scraping the data from the web, because sometimes
Okay.
data is not available. You have to download it from the web. Okay. So you should know how to download images. So for images, there is something called as DuckDuckGo. It's a website where you can download images for free, and there is an API for it. So I recommend that for all these different modalities. Okay, all these different modalities, you at least figure out, okay, some scraping libraries. Okay, if you do it in your CV, right, it will show that, okay, you have worked extensively on a set of projects beyond data science. Okay, you know at least how to collect data, which is the job of a data engineer, but you are well versed with it. Okay, all right, this is important stuff. Okay. One more project that I should suggest you, which I don't think you guys have done. You should have done, by the way. It was initially, I think it was, I don't know why it is not included still in your curriculum, but it should be there. This is related to time series forecasting. Okay. So I will not go into the deep learning libraries, which are, by the way, the best ones on time series forecasting data. But you guys please read about the following two algorithms: auto-regression. You know regression, right? So it will not take you much time to understand auto-regression. And you also read about moving averages. Okay, so auto-regression is written as AR and this is written as MA. So there are integration of auto-regression with moving averages. So there are algos which combine AR with moving averages. Okay. So they are called as ARIMA, auto regression integrated with moving averages. And there are so many variants of it. Okay. So maybe read about one or two variants. Okay. And you should do some analysis on a time series forecasting data set, be it sales forecasting, be it, I wouldn't recommend stock market because that is very difficult to kind of process, and also very difficult to identify patterns from it. But sales forecasting is something that you can all do. You can think of virality prediction. So you can see how, so do you know that like from YouTube, you can actually see the view length or the number of views over a period of time. Have you seen that? If you have a YouTube account or YouTube channel, you can actually see how many views are coming to your video.
Yes.
So can you figure out, okay, if it will become viral or not by identifying the trends from the number of views? Okay,
Yes.
there are many such data sets available online. So maybe make use of one of them and incorporate it in your CV. That would also be very nice. Okay. By the way, if you are interested, the best resources or best algorithms in this case are this LSTMs, long short-term memories. Okay. But this is from the deep learning realm. Okay. I wouldn't recommend it unless you know about deep learning. Okay. So basically, unless you know about different types of neural nets, I wouldn't recommend going with LSTM. But at least this is something that you could do. It will not take you much time. Okay. It will require maybe say a period of 8 to 10 hours for you to finish everything. Okay. So maybe search for a YouTube video, you'll understand everything. Okay. But this is something that you all could do. But do it on a nice data set that you collected, that you scraped. Okay. And that will have more emphasis, and put it to your GitHub repository and highlight it. Okay. So maybe find a niche application like sales forecasting or view prediction. Okay. All right. Okay. So this is another set of project. Maybe let me think. Okay, if there is anything else that I could recommend you guys. Okay, so you have done classification, regression, clustering. Okay. See, I'm not really sure if you would be able to integrate. Again, that falls into the realm of deep learning. Okay, I think these are more than sufficient, at least from a beginner standpoint. If you want to venture into this area, these projects will give you a quick head start. These are from my side. Okay, I'm not saying these are the best projects, but this is something that you can definitely explore to, to spike up your CV. Okay. And these are some projects which you will not find anywhere in a data science profile for sure. Okay, even GUI people, they don't know about these projects. But so this is from my side to you guys, since you are my students. So I thought maybe I can discuss something which I am working on, and probably you can also take benefit from it. But there are a lot of other cool things which are happening. I do recommend that you please keep track of a YouTube channel called as 2-Minute Papers. Okay, do keep track of this. Okay, so that you see what is going on in the realm of ML and DL. Okay. This is a cool YouTube channel. I don't sponsor it, but it's something worthwhile. Okay, I think it's from a Russian guy, but a very cool YouTube channel. Post 2-minute videos, 2.5-minute videos, 3-minute videos for the recent state-of-the-art machine learning and deep learning research. It's very nice. He posts almost every week. Just subscribe to it, or maybe just watch what has been done recently. You will appreciate it. You'll appreciate it for sure, and that will make you love the world of ML more and more. All right. Any other questions from your side before I give you some projects to do? Maybe say some data science related stuff which you can practice upon. Any questions from your end? This is my last class with you. Okay. If anyone has read the questions that I sent earlier, if you need some answers to those, because I doubt, see, obviously ChatGPT will give you most of the answers, but some of them are tricky. So maybe ChatGPT can give you wrong answers as well. So if you want to know the correct answer, maybe just ask or do Google a bit. Or shall I tell you maybe one more interesting project? It just struck me. Shall I tell you one more interesting project? And this is
Yes.
along these same lines. Okay, this is along these same lines. This is actually being done by one of our groups. Okay, so I'll tell you the motivation behind this. So what we have in the world right now is, I say that always now there are two oracles with us. There are two essential gods in the technological world. One is the OpenAI's ChatGPT, or tools along the same lines which can understand natural language text very easily, and the other one is Google. Do you see the subtle differences between the two?
Yes.
What are the subtle differences?
Google will give us the links in the document that you can go and refer. But when it comes to ChatGPT, it will summarize and give you the problem statement what you are searching for.
So where is what is that in which this OpenAI's ChatGPT is limited, but Google is not? And what is that in which Google's AI is limited, but ChatGPT is not limited by that?
This ChatGPT guy is limited with the 21, the year of 21, and this Bard guy was having the internet connection right now, and Bard don't have Bard having some kind of a characteristic limitation. I think I'm not sure about how many words, but this ChatGPT guy has more.
Okay, so I'll tell you definition to, yeah, you're right. There are two limitations, one of each. So one guy is essentially not able to summarize articles. Essentially, it doesn't put up a summary for us, which is the Google's website, the search engine. And the other is limited by what we say is the data, because it cannot fetch relevant recent articles. Okay, it is, the bottleneck is there. So what we are proposing is, so essentially, if you look at the ChatGPT project, right? Okay, this one which I gave for Python articles. Okay, this one for Python articles. Now, do you think you can integrate both of them? Actually, you can. So currently, I'm saying that you retrieve PDFs, right? Why don't you use Google search engine, okay, to retrieve these articles on the fly? So you really don't have to store them in a vector database all the time. Do you realize this? So you can only store a vector. So there are databases which are very popular, which are super fast, not like MySQL and all. Have you read about vector databases or Redis database and so on?
No.
Okay. Telling you, okay, there are things beyond. Okay, so currently what you do is this. Okay, so when you are retrieving these PDF articles, right, retrieve them on the fly using Google. So that's where you get what we say is like the recent, the recentness, okay, recency bias. Okay, so Google will fetch you the most recent articles. Okay, and whatever Google fetches, you have the question posed by to the chatbot, right? Question to the chatbot. You can fetch the text from Google from the top 2-3 articles. Give the question to ChatGPT and ask it to fetch, because ChatGPT is really good at natural language understanding. So you can ask ChatGPT whether there is some piece of text in the articles that you fetched from Google which is relevant to the question. So essentially, you are doing prompt engineering here. So you give it to ChatGPT the question, as well as the question posed to chatbot, as well as the text that you fetched from recent articles. So ChatGPT will make a summary according to that question and will send it back to the user. Okay, so we are building an app in this. We have integrated what we say is speech to text libraries so that even disabled persons can use it. So it's like Alexa or Google. So speech to text is there and text to speech is also there. So we are using React Native. It supports speech to text as well as text to speech. So we are using some libraries from that and building an Android app for it. You can also think of making a web app. So this is something that one of my student groups is doing. Another I will tell you is what we are doing right now. It's a fun project. We are making use of ChatGPT. It's again related to data science only, but it's more of a game. Is there anyone who watches Friends? Or still has watched the Friends season? Is there anyone who has watched it?
It's in my, wish list,
Okay,
watch list, I would say.
aware of what Friends is, right? I mean, the season.
Yeah.
A story of 5 friends, essentially.
Yes.
5 or 6, I don't know. Okay, I have watched a couple of episodes only. Okay, so there was this episode where this guy Ross, who's one of the friends, okay, he prepares a trivia, and the 4 other people they participate in teams. So 2 girls are in one team, and Chandler and Joey are in the other team. Okay, so Monica and this what's her name, Rachel. Okay, they are in other team, and this Chandler and Joey, they are in the other team. So it's like a trivia game where what they are doing is Ross has created a set of questions, and the questions fall into categories. So what they do is they pick these categories one by one. And once you pick a category, so a team picks a category and they have a question from that. If they answer it correctly, they get points. Otherwise, there are negative points and so on. Okay. So it's like KBC. Okay. It's like KBC. So we are making use of ChatGPT to build a KBC, a very nice interactive environment, an Android app where you can speak to it. So it's like a speech to text recognition. So we are building this trivia fiesta. You can actually ask ChatGPT to create questions from any domain. Yes or no? So we ask ChatGPT to create 10 MCQ questions on any categories. So we are thinking of it like this. Give me a set of categories. So the user will say, okay, these are the categories. There might be multiple teams who can be playing it. So we want to, harness the power of ChatGPT for making this trivia game, similar to what those people did in that episode. But we want to do it on the fly now that we have an Oracle. Okay. Previously, we didn't have an Oracle, right? You have to come up with a set of questions and you have to put it in your database. Now you can do it on the fly because there is someone who knows about everything almost. Yes or no? Okay.
Okay, so fly is in.
On the fly means that basically dynamically.
Okay.
So it's passive. Basically, we are not storing the question in our database. So we ask ChatGPT. So when you create the categories, right, it makes the questions at that time. Okay.
Okay.
Does it make sense? I mean, we are not storing the questions anywhere. So when you define the categories, we then store the questions created on the fly. When I say on the fly, it means dynamically at that time.
Okay.
The game begins, and you can have a positive scoring, negative scoring, and there is a prize money. We are thinking of making it for the disabled because it's a voice-enabled app, so you can talk to it. There is a trigger. We are calling it as Misty right now, but let's see. So okay, let's see where we go with this. So we are doing improvements on it, changing the environment so that it looks nice on the Android app. You can think of making a web app or a tablet app where many people can do. Just a second. All right. Any other things about this or?
So for the Python article scraping, we were using the Beautiful Soup, right? So like that, is there any API for, as you said, like for ChatGPT, we'll have some API, and then for Google,
API?
we'll have an API, right?
There is an API.
So,
yeah.
Can you give several API names for Google and ChatGPT?
You have to exactly. So basically, an API is nothing but a call to the server. So
Yes.
you have to register. Yeah, you have to provide your user credentials.
Mm-hmm.
Just like you give an account, right?
Yes.
Okay, maybe I can send you the this ChatGPT API code to connect.
Okay.
Okay, I'll send you that. Okay, it's 8 to 10 page, not 8 to 10 page. Sorry, maybe 8 to 15 lines code. Okay, I'll send you that.
Okay.
I'll put it in a what you say, a directory called as projects, which you can explore.
Okay.
All right. Anything else I can help with? These things are common, Beautiful Soup and all that. You just do a Google search, you will find the link. Even for OpenAI's ChatGPT, If you just do a search, you will find that 8 to 10 lines piece of code that I'm talking about. I also leverage it from Stack Overflow.
Okay.
So, I mean, if you just Google it, you'll get the results for sure. Yeah. But if not, let me know, and I'm always available. You can drop a message to me on LinkedIn, and
Okay.
I can send you even more project ideas to do. It's just that you have to do it, right? I mean, I can share the ones that I'm building, but they might not be what we say is appropriate for your
Yeah.
journey, right? Okay. So any other questions about this? After this, I'll maybe share some a little bit of homework assignments for you guys that you can do in your free time. Okay, there is no constraint
Okay.
from Goovy's side. So maybe you can test your skills and see if you're able to do well on those. But before we do that, any questions from anyone?
No, from my side.
Anyone else with any questions? See, the world of possibilities is right now limitless. So any ideas, if it strikes you, you can still, I mean, you can do it for sure. Any idea, if it comes to you, okay, that is implementable by the technologies that you know. Okay. All right. Anyone?
So, like when it comes to this project, like we were talking about this chatbot project, right? So I can use it's not mandatory to use as like built as in mobile application. I can use the web applications like.
You deploy it on Flask, you deploy it on, say, Streamlit.
Okay.
I have a Jupyter notebook which runs, and maybe there is a nice like one web page that you connect to. Okay. So where you press button, just modify like how the input should be. It's up to you. Okay. We are thinking in terms of a voice enabled app. Okay. Because we wanted to enhance the reach.
Okay.
Yeah.
So because right now I wouldn't say that I'm that much familiar with Streamlit, but I'm a little bit familiar with Streamlit. I'm going into the documentation. I'm going into Stack Overflow and all those. But
I mean,
Flask is totally new to me, so I need to take a
yeah,
like
let me just tell you this. Okay, any new technology, it's just nothing but a set of instructions. Use it as you desire. Okay.
Okay.
But to explore, okay, I mean, widen your horizons. If you don't do it, you'll be limited by just one or two.
Okay.
Okay. That a company doesn't want. Okay, they want
Yeah.
width. They want width. Depth you will see when you join them. Okay, but as of now, they want width. You should be aware of almost everything that is out there, or at least say even a 5% of it. If you are aware, then you are a decent candidate for them.
Okay.
So
Is this Flask and all those? I've read about it, and I think there is videos in Gooey also.
see, there it is. You can find Heroku as well. You can do deployment on AWS Dockers. Okay, there is no limit as such.
Okay.
You have to start. Okay, it's just that you have to put in your efforts. Okay, I'll tell you about maybe one more interesting thing that you can do. So currently, I've spoken about these Python articles, right?
Yeah.
I'll give you one more article, maybe one more application where you think where probably it would be nicer, maybe from your standpoint. So let's say if you are driving and you get hit, do you know of the legalities about it? Like what you should do, whom you should call, what are the numbers for it? I mean, you only call the police, right?
Yeah.
But do you really know like how to claim all that and do the legal stuff?
The insurance and all those, right? Like I need to Google for each and everything.
You need to Google it, right? Okay. Why don't you
Yeah.
chatbot for it? Does it make sense?
Yes.
Okay. So see, that's why I'm saying these are oracles with us. Make use of them and find a niche application for you.
Okay.
So it just struck me like I can discuss all these things and you can make nice applications out of it. So that's why I said possibilities are endless. It may be that like after the session, maybe within a day or two, you are walking and you come up with a nice application and it will become viral. Okay. If it is useful for many people. So think along these, make something which is unique. Okay. Which has a nice proposition. And let me tell you, if you get viral, I mean, there will be no limit to the opportunities that you get.
Sure.
Okay, all right, I'll show.
And would you recommend Udemy to the people, Sanity?
Okay, see, I wholeheartedly recommend every resource. The more you can gain, the better. Okay.
Okay.
There is no resource which I don't, I mean, which I do not recommend, unless it is written by someone on maybe a website which is not rated highly, or where you see false information. So other than that, every resource is something that you can refer to.
Okay.
All right, I'll share some articles now, or maybe some assignments for you guys that you can practice. Probably you can appreciate the data sets that I'll be giving you. I'll be giving you a subset of the data that I have, because there are legality issues. I'll show you the data, and then we can discuss more on what can be extracted and what probably you shouldn't from an ethical perspective. Okay, I have prepared a set of questions that you could do, and beyond this, you can have your own set of questions. Okay, so just give me a moment. Okay. Just let me know if you're able to see my screen. Yeah. Can you see the screen now?
Yes.
Okay. All right. This is. You have to find those projects. Okay. I mean, I don't know where they'll be kept. And just give me a moment. I will be able to locate it in just a few minutes. By the way, is there anyone who has heard of Interview Kickstart?
Is it interview?
Interview Kickstart. Have you heard of this organization's name?
I think I've seen it somewhere.
Okay.
Just now I was surfing at your in LinkedIn, and then I've seen it, I think.
No, I'm asking this because I've just joined this organization. They are doing really well. So I just wanted to know, like, so they have just ventured into India. It's a US based company, very popular in the US. Okay. So I am one of their, what we say is like mentors or instructors, you can say SME and TAs. And I mean, I do a lot of things for them. So I just wanted to know if you guys are aware of it or not, because they have just ventured it. So they are similar to what we say is Google. Yeah. So just wanted.
Oh, okay. So they were also similar to GUI.
Yeah, they're also similar to Google. I mean, not from the edtech standpoint. Okay. Google has a lot of other domains as well. Okay. Okay. I think this is
like Jonathan.
What's the?
What's the product like? What's the main aim of the company?
I mean, they also do a lot of what we say. So it's an edtech, but targeted towards AI engineer side. So people who are professionals working in the industry for like 13, 14 years and so on. Okay. And they want to transition into, say, manager's position and all that. It's for them.
Okay.
Okay.
Because the name is like sounding different, and so
but they are the same guys, but they are more inclined towards like AI engineering and ML engineering side, and it's really expensive. Okay. Unlike Google, it's really expensive.
is it like what do you call, like a paid thing, or like open source?
It's a company which offers edtech services like Google. I'll tell you, for the US cohort, they are charging around $10,000.
Damn.
So, and that's why I said it's really expensive. Maybe in India, it's not that expensive, but so, I hope you can relate. That's why I said they just ventured.
Yeah, totally.
Okay. So it's there for professionals who are already senior managers, but they want to transition into another domain. Okay. All right, so this is something, yeah, I think you can all do this, okay? This would be nice for you guys, okay, just a second. Okay, what was the, it's called as, okay, let me just share this first. Okay, maybe if you look at the chart window. Come on, it's not pasting. Okay, you can just bookmark this link. I'm going to send you the data set just in a bit. Okay, give me a sec. So I'll tell you about this data. It's a real data set. Do you guys know about, say, Opera web browser?
Yes.
It's not very popular right now, but it used to be around 5 years back, before Chrome and Mozilla kind of shut it down. Okay, so the idea is this. Okay, let me just show you the data. So you have the users here. I mean, so basically for a, are you able to see the data set?
Yes, we do.
So the first column is talking about a unique user ID. Okay, so the data is recorded from a session of a user. So it's a unique user ID. It's the country from which the person is, what kind of internet service provider the person is using, what website they are visiting, the time. You can see that the data was collected in around 2030. Okay, device. What's the type of device they are using? What's the screen width and screen height? It's probably going to be a tablet. Then what type of domain category it is? Like, is it a social networking website? So I know that Facebook is a social networking website, right? So these websites have what we say is a corresponding domain category, on what day the browser was installed, and how many web pages under the Facebook domain name the person visited. So this is the data which is given to you, and then you can think of like what kind of information you can extract from it. So when I did this task for the first time, my objective was to figure out like what relevant ads could be provided like to a user based on their past history, and the other was like if a tablet company contacted us and they wanted to know, okay, what other suggestions could be given to them, could be given to the users. So this was my job when I worked with this data set, but this was long back. Okay, but this is something that you could work on. This data set is still used in practice, okay, by the company that I work for. These are some of the questions that we targeted. Okay, so you can see these questions, maybe add your own experiments inside from this data set. Okay, I would recommend that you don't release it to LinkedIn, proposing your own. Otherwise, you'll get maybe blacklisted from LinkedIn, or I mean, some repercussions can be there for you. Okay, because this is proprietary. Okay, I'm sharing this from my side, so recommending that you don't release it.
Yeah.
All right, I mean, you do it for yourself. Okay, you do it for yourself. Okay, so see how much you can do. Some of these questions are a little what we say tricky. They will require you to be really good with pandas. So do explore and see how much you can do. Okay, there is one more which I saw from a LinkedIn post, which is a simpler one. Okay, I'll just share that directly. Give me a sec. I think I have it here. Yeah, here. But this I saw from a LinkedIn post. I liked the post. Okay, so I think you can certainly get some benefits from it. So this is your project. I mean, maybe say take home assignment. Okay. Example task 2. But these are all data science projects only. Okay. 1 second. You can download this file. You'll get it probably in 10 seconds. Okay.
Sanatan, I have a question.
Yes.
Can we use Streamlight for a complete project?
For
Streamlight for a complete project.
I don't recommend it. Yes, you can. Okay, as in like if it is about just creating a web app, you can. Okay, there is no harm in it. But see, because Streamlit is open source and like the project, this particular library Streamlit, right? I don't think many people are contributing to it right now. So it's I wouldn't say it's obsolete, but it is not very popular. I recommend that you do it in Flask, which people still use to date, and also Heroku. Okay, that obviously you can do all the things in Streamlit. Okay, but you have to search. Okay, it's because Streamlit has its own set of instructions that you have to write. So you can do almost all the things in all these libraries, but I am trying to suggest here like the recency is more towards Flask and Heroku. I would even say don't use Flask, go with Heroku, and perhaps read about Dockers. Okay.
Yeah.
Okay, read about Dockers. That will. So that is what the industry uses nowadays. Okay, they are called as Docker containers. Maybe if you explore a bit, you will know more about it and why it is preferred over these other web deployment or just deployment apps, you can call them. Okay. There are no issues as such with the Docker container in comparison to like services like Streamlit, Flask, because they are dependent on a lot of other packages. But Docker doesn't have that kind of a limitation. Okay. You will once you read about it, you will realize it. Why I'm suggesting Docker. Okay. All right. Anything else? Any other things? Okay. So these are some interview questions. Probably you just go through it. These are not that great, but I think you can still benefit from it. This is what GUI people gave me long back. So I'm putting these questions for you. Okay. Maybe you can use it. Okay. So this was shared with me by GUI people. These data science questions. So they have engineering questions as well and all that. Okay, but I mean go beyond. Okay, this is not the only thing. Right.
I have another question. Scraping of data from LinkedIn is illegal or?
No, it's legal. It's legal. Oh, shall I tell you some interesting projects that we are doing on data scraping as well? Since you asked. We are actually doing one project from LinkedIn. Are you interested?
Yeah, sure.
So, Sanatan, before we proceed further, like we can scrape data from any websites or it's
Anyway, there is a limit, obviously. So the number of requests that you can send to a website, it is limited to the number that they have set. So I think for LinkedIn, you have 1,000 queries.
Okay.
Okay. So you cannot go beyond that number. I mean, you can be intelligent and maybe query from another IP. So ask it when to run it, and then you remove the duplicates. Because when you scrape data, obviously duplicate data would come, right? From different IPs, from different say, computers. So you have to deduplicate it later on. Okay. But that can be done. Okay. It's just, see, you have to do a hack, right? Yes, sir. Okay.
Yes.
All right.
Because we don't know like for what website we can scrape data or what website we do not.
Everywhere. So this beautiful soup that I'm telling you, right?
Yeah.
This is like this scrapes data from the HTML page of the website. Okay. So essentially what it says is this, what it does is this, that think of a primary web page, okay, like the index web page. And what it will do is it will try to go recursively within the web pages in the index directory. I don't know if you have worked with a HTML project or not. So index page is like the main web page, like the title page, and then there are pages that have direct links. Okay, so it's like recursively traversing these directories, and in each directory you have these web pages. But nowadays web pages are dynamically created. Even though web pages are dynamically created, you can fetch content from it. So have you actually looked at any web page? You have right clicked on it and looked at the source.
Yeah.
Okay, so but you still see all the data from it, right? From the website.
Yes.
And that data is actually fetched at the time of loading. So nowadays, dynamic web page data is there. It's not that these pages have been pre-created, like the format pre-created, but like the values are being fetched from a database. So what you can do is like you can scrape data from with the help of a library, okay, and keep it in your database. And you have to be careful about what is the format of the database, which tags, through which tags you want to probably get the data. Because see again, are you aware of XML and JSON formats?
Yeah, XML I'm aware of, and JSON also.
Tags, right? In XML and JSON. HTML also has tags.
Yes.
So each tag has a name. Yes or no?
Yeah.
So you can think of it like a column. Okay. So this tag will contain text from each web page. So let's say you are only concerned about downloading the prices. So you will download only the price, right? Not I mean nothing else. Yes or no?
Yeah.
You don't want the entire text. So these scrapers that I'm telling you, they can get the data only from the tag that you're interested in, because the tag is not going to change. Only the value will change for product to product or page to page. Does it make sense?
Yes.
Okay, so you can specify, just play around with Beautiful Soup. It's a very nice library. Yeah. Okay. So talking about the LinkedIn project that we are doing, again, it's a data analysis project. You guys would have heard of the recent layoffs that happened, right?
Yeah.
Okay. So so I'll tell you the motivation about it. So because there were a lot of people who were being laid off, and obviously, like it's not that only tier 3 companies are offloading, right? Like tier 1 companies are offloading more. Yes or no?
Yes.
So the idea was, like these are really good guys if you think about it, like people who are being like you can say they have been asked to go from their respective jobs. So they are really good guys, like people from Amazon, Facebook, say Flipkart, Meta, and all that. Like a lot of layoffs have happened. So we wanted to see obviously these companies will be restructuring, right?
Yeah.
Okay, so we wanted to analyze where all these good guys are going. I mean, obviously, restructuring will be happening within these companies, right? These big companies. I mean, if you Google, you will not go to a company like apart from say Fang, or maybe you will go to a company which is working along the similar lines, right? You will not change your profile entirely. Yes or no?
Yes.
You will
Yes,
tap
yes.
the company alone again. So restructuring is going to happen within these organizations, these big organizations. So we wanted to analyze why it is happening, in which sector it is happening, which area has been hit the most. Okay, which you can say technology is being used or is being learned by these people. What are the recent changes in their profiles? You can say that, okay, at what position they were in, now they are hired in what position? Okay, is it a downgrade or is it an upgrade? So we did this layoff analysis in somewhat detail. We are still working on it. We will publish a paper soon on it. So that was the idea behind this LinkedIn scraping. We use Beautiful Soup only for scraping the data. Then we had extensions to this. So there are other websites which keep track of it. There is another nice website which is called as Layoff Tracker. Okay, yeah, this website. So we analyze the data from this website also, kind of merged it with our LinkedIn. Okay, so it tells us, okay, which people have been laid off, how many employees have been laid off. It talks about the specific people who have been laid off and all that. Okay, you explore about it. I mean, there are, I mean, you can get intricate details. Okay, so I mean, just go through this website and do a little bit of digging. You'll get exact details. Okay, you'll get exact details about tech and non-tech layoffs.
Oh,
Okay.
and it's showing today's date, and today also 178 people.
Yeah. So it is happening for probably the last maybe say last 12 months or 13 months now. So I think 15,000 people got laid off just last week. I don't know from which company. So a lot of restructuring has been happening. Okay. So obviously not everyone is becoming what we say is like unemployed. Okay. Restructuring is happening across these companies. So maybe one company is shifting focus from one domain to the other. So they are hiring on it in other. Okay. And people are quick to adapt. So that this was like one of the motivations of our project. So this was done on LinkedIn data. I'll tell you one more, which is kind of, I wouldn't say it is still relevant, but I mean, back then it is still relevant to this date. You can still say it. Do you remember the Russia-Ukraine war? It is still ongoing, by the way.
Yeah.
We did the analysis for that also. We used data from different social networking websites, even LinkedIn. Okay. And made, you can say, a tracker. What is happening, which area has been invaded, okay, how much infra loss has happened using like hate speech detection and all that. So we made like a whole big, I mean, we are writing a journal paper for it. Probably once it is published, I'll release it for you guys as well. Okay, so such are the kinds of things that you can do in the data analysis realm, data science realm. Find an interesting problem, a recent problem, and try to tackle it. And the more recent problem that you find, the better it has chance to be accepted in the community. Yes or no? I mean, think about it. If you would have done this analysis, the project would really shine in your CV. Okay, maybe you can still do it. Okay, see, the way you do your analysis would be different than mine, right? Think along the same lines. Okay, not so you can target these two problems again. Okay, and do some simple scraping and build your you can say projects on GitHub. So there is no limitation as such. So since somebody asked me, okay, can we scrape data? So I thought maybe I can share this info as well. Possibilities are frankly endless. I mean, if you ask me on another topic, I'll tell you. Maybe I'm associated in those directions or not. Okay. So yes.
Yeah, for the front end, are you recommending React?
I recommend React. I recommend Vue.js. I mean, for the backend, I recommend Vue.js. Even I recommend Bootstrap.
Yeah, Bootstrap is the default. Okay.
Yeah. Okay. So see, any type of scripting language would be nice, which supports scripting, right? Any type of web development language which supports a decent amount of scripting would be nice. Okay, so I mean, React and this Bootstrap are the common ones. Just stick with one. Okay, just stick with one. Okay, you don't really have to build a fancy website nowadays to attract people. See, if your content is good, see, think of like Google search engine. Is it fancy? No, right?
No.
All right. So I mean, it just has a single search bar and the name. So, but if you bring in more value, people really don't care about. I mean, obviously, you can work on the aesthetics and all that. And for that, React and Bootstrap are nice. But my knowledge on the front end is very limited, to be honest. Okay. I used to just pick up code snippets from, you can say, Stack Overflow and all that. So I just search, okay, or maybe use ChatGPT for it, for the front end part. Okay. I'm not really good with like web technologies. I mean, so the way I can write Python code, I cannot do the same for web technologies. That's what I'm trying to put here. But I understand every bit of it. Once it is given, I can actually accommodate and build projects for it. But not not experienced in that regard. Yeah.
When it comes to CV building, right? Like we used to build a CV like hereafter, right? So in that, I would give Python, Pandas, ML, or the Power BI, Tableau, and all those. So if I'm adding this much of uh, technologies or languages that I know, it'll add me an advantage, or it'll add me more complexity when I'm going to the
Again,
interview.
I'm saying width is more important than depth. I'll repeat this, width is more important than depth. Okay. See, because nowadays companies receive a lot of CVs. Okay. So if you are comfortable with more, it's more, I mean, your CV has more chance of getting shortlisted. Nowadays, people are using tools to scrape
I've also
text
seen
from,
that.
yeah. So make a very short CV, 1 page, but it has to have a lot of information, only meaningful information. So, I mean, there are tons of posts on any of these job marketing websites like LinkedIn also. Okay. Just take a default template. Okay. Put your content there. Okay.
Okay.
I think so. See, for big companies, they use specific tools. So they have to pass, I mean, the CVs have to pass a certain standard for it to get shortlisted. You can use one of those templates. Okay. So you will find thousands of such posts online. They just talk about your CV building.
Okay.
Okay. Just
Because
download. Yeah.
on yesterday or something, only I've done watching the Power BI video in GUI, and now I'm going into Udemy to get more insight about it.
All right. Okay. See, make use of as many resources as you can. Okay. Don't think if a resource would be irrelevant. Okay. So just make use of anything that you can get. All right. All right, I'll stop here. I wish you guys the very best. I hope you have downloaded all the things that I've sent in the chat. I'll close the session in 5 minutes. Okay, I'll upload this batch is the S1.
So from tomorrow, and as an instructor will.
I don't know whether from tomorrow or next week onwards. I'm not sure. Okay, I'm just going to convey to the to Rekha or whosoever is there. Okay, that I am done with your batch. I have completed all the things, and they will assign you the next mentor, whosoever it will be. It will be either Shabrinath or probably what's his name, Netaji Nirmal, or maybe one more guy, Kaushik. So it would be one of these 3 guys. Okay, it would be one of these 3 guys. Okay. Today is September 30th. All right. So see you around, guys. Take care. Bye-bye. And if you need any help, you can just reach out to me on LinkedIn.
Sure.
Bye, everyone.
And thanks for all your thoughts, and thanks for your stuffs that you're giving. Because initially, I would say, I was literally, I would say what I would say, I was literally afraid of asking stuffs, and I was faced little bit of discomfort. Then
don't worry. Okay, I mean, you see, I will again put it like this. You have a right. Okay, you have paid the money first, so don't think twice. Okay, don't think twice. Okay?
Yeah.
Always ask as many questions as you want. Think of, I mean, lose your inhibitions. Okay, don't think of what other people would think about you. I mean, many of these people would not even know you. Okay, so people are shy to ask questions. So that's what I'm trying to hint at. Okay, all right. It was lovely interacting with you all. I especially want to thank you, Rajesh and Shilpa. So these 3 people were like very, very, very interactive throughout the sessions, and that kept my enthusiasm up. Okay. So that's it from my side. I wish to connect with you on LinkedIn, and if you have time, or if you need, let's say, any sort of assistance, do reach out. Okay. And I can help in expediting some of your applications once you have applied. Okay, not before that. So once you have applied to a company, you can drop a message to me saying that this application is not going forward. If you can help in this regard, I'll try my best. Yeah, I'll try my best. I can only help if some acquaintance or a relative or a friend is there in that company. But I do have a lot of friends, so hopefully I'll find someone for sure.
Sure.
So, bye everyone. Take care.
Bye, Santil.
Bye bye.
Thank you.
Yeah.
Bye.
Bye bye.